We're back to our timeline here of the theory of evolution, and we're getting a little closer to when Darwin was actually born. So the very year that Darwin was born, a scientist named Lamarck actually published his own theory of evolution. So we're going to take a closer look at Lamarck and his specific theory. Now, Lamarck was not by any means the first person to come up with some ideas of evolution of species, but he was the first person to not only say that species may be actually evolving or changing, but he proposed a mechanism for that as well. So he is most known for this idea of use and disuse. So by use and disuse, he felt that there was some connection or relationship between an organism and its environment. And basically, organisms were interacting with their environment, and if they needed a specific trait then or appendage, then they would enhance that, or that would get larger, stronger. And if they didn't need something, then that would eventually go away, such as a snake. Think of a snake, perhaps it used to be a lizard. If that lizard did not need its legs, the legs basically went away eventually. So oftentimes you see the giraffe example when we're talking about Lamarck. The giraffe needs to be able to reach the leaves that are high in the trees. So the idea here is that the giraffe basically evolved a long neck so that it could stretch up into those upper tree branches and get the nutrition that it needs. So perhaps the giraffe started with a very short neck, it stretched so that it could reach more leaves, and then eventually this became a very long neck. So the idea here is that based on this interaction with the environment, if something is used, it's going to be enhanced, and if it's not, it's going to go away. So we can take this idea and look at it in relationship to traits today. We can certainly see some examples where if an individual uses a certain part of their body, that would become enhanced. Think of a muscle builder, a bodybuilder. They obviously have very large muscles because they're working out and they're enhancing those. So they're lifting weights regularly, watching their diet, and as a result, we do see that their muscles become much larger than they were to start with. So that's one example. If we look at some different cultures, if we look in Thailand, for example, some cultures believe that a very long, slender neck is very attractive. So the women there work very hard to get this long, slender neck. They do this by placing rings around the neck of small young girls, and then as the neck elongates to accommodate these rings, they add additional ones. So when you look at the older women, they do have these elongated necks. Now, one place where Lamarck went wrong is that he believed that these characters or traits that we're looking at, these are what we call acquired characters. He believed that acquired characters or traits can be inherited. That was one thing that he proposed and felt to be the case. Well, think about what he's saying there. If you have this bodybuilder, he now has very large muscles because he did work at that and they became enlarged. If he has a child, is that child going to automatically be born with large muscles? And I think we know and understand absolutely not. We're not going to have this child that now has large muscles just because dad was a bodybuilder. Same thing with the woman here. These cultures have been adding these rings for many, many years, but you still have to start from scratch when we're talking about a young girl here in this culture, because she's going to be born with a normal neck, and then the rings are going to have to be added to elongate that neck. So just because mom has elongated her neck does not mean that the child will automatically already have that. So Lamarck was wrong in that regard. The acquired characters that an organism may come up with over their lifetime, they're not going to be passed on to the offspring. So no modifications acquired by an organism are going to be passed on to the offspring. We now know that to be incorrect about Lamarck's theory. What we do have to keep in mind is that while Lamarck was wrong in a number of different aspects of evolution, he did recognize that species can change and that species do change and that the environment does have some influence on that. And he did publish this theory, and this would have been a theory that Darwin was exposed to as he did go towards formulating his own theory of evolution. So if we talk about Charles Darwin a little bit, Charles Darwin came from a very educated background. His father was a physician. His father actually wanted him to become a physician as well. So he was sent initially to medical school. He did later leave, not having any interest in medicine. And he then studied botany. So he was exposed to a lot of different scientific thinkers of the day. He had access to the books that were published by many of the people that we've already talked about in the first part of this chapter. So he read about Lyell and his thoughts about geology. He was exposed to Lamarck's theory, and eventually he did come up with his own theory of evolution. Now, a lot of his evolutionary ideas were sparked when he took his trip on this ship called the Beagle. So the Beagle was a ship whose job was to basically map the coastline of South America. And Darwin was on board this ship basically to be the naturalist. So his job was to go on shore as they went around the different coastlines and catalog the various organisms that he saw there. So not only catalog the different plants, but also the different animals. He did a lot of sketching, making notes of these. And so he did note a lot of things that were unusual about the organisms that he did see in these different locations. Now, one place that you hear talked about a lot with regard to Darwin is the islands in the Pacific, specifically the Galapagos Islands. The Galapagos Islands are small islands. They're off the coast of South America. They're in the Pacific Ocean, but they're very isolated from other land masses. But if we had to say which landmass they're going to be closest to, we would have to say South America. So the Beagle did voyage around the Galapagos Islands, and Darwin had the opportunity to get off the ship and to visit the land masses, catalog the different life that was there. And so here's a closer look at these islands. And what Darwin noticed when he went on shore these islands was that the life was very different. He found a lot of very unusual organisms that he hadn't really seen anywhere else in all of his trips. And he also noted that it was most similar to the closest landmass. So it was most similar to organisms or life forms that you would find in South America. So he noted that although it was very different on these islands, it was most similar to what he was seeing on the South American coastline. And this was regardless of the fact that some of the climates were more similar to places, say, in Europe. Regardless of those climate matches, they were still organisms that were most similar to what he found in South America. So he looked at all of the different organisms. He noticed that while there was a wide variety of life forms there on the islands, that a lot of them appeared to be very similar to each other. So not only were they very similar to each other, but they had developed or they were displaying unique characteristics that enabled them to occupy certain niches in the environment there. There's a lot of talk about the birds that he observed there, and those have been now designated Darwin's finches. So Darwin's finches were just a lot of different bird species. He noticed that they were very similar to each other, but they had adaptations or they had unique beaks and other characteristics that made them well suited for what they were doing there on the islands. So here we just see an example of some of the different finches that he described. He noticed that the beak shapes were unique for the type of food source that they were going for. So he sketched a lot of the beak shapes. He really came up with a lot of evolutionary theories based on this idea that there was some kind of a match between the environment and the individual species. So this in itself is not so different from what Lamarck was proposing, that there is some kind of a connection between organisms and their environment. Ultimately, Darwin did put all of his ideas together. He did publish in 1859, The Origin of the Species. The Origin of the Species was very revolutionary in its time. And this is where Darwin really laid out the different concepts that he came up with in describing evolution. So what he proposed was two major concepts. He said that there is descent with modification, so that was number one. And then the second thing is going to be natural selection and adaptation. So we're going to take a closer look at these two major concepts that Darwin explained in his Origin of the Species. So when we talk about descent with modification, basically what he was saying here is that there is a common ancestor. So while organisms may look pretty different from each other, at some point in time, they had a common ancestor. That's what Darwin was proposing. So he really looked at life as basically a tree. And you have various branches on that tree. And where we have the forks in the branches, that would be where the common ancestor was. So if we have a common ancestor right here, that ancestor is going to live for a while, and then there's going to be some changes or adaptations that take place. And maybe some organisms are going to change this way and some are going to change this way. So that maybe these now look pretty different from each other. And again, this is because of some kind of change in the organism from what it had in the ancestor. And then these are going to change more and more until we have a whole bunch of different life forms. So what Darwin was saying is that there is a huge amount of life forms, and these really all can be traced back to a common ancestor. Now, not only that, but he said that organisms that would be close on the tree, such as these, are going to be more similar than organisms that would be, say, way over here. Okay, so that's what he meant by descent with modification. We have a common ancestor. There's going to be some changes along the way that cause the various species to diverge or change from each other. And those are likely changes in relationship to the environment. Now, he also said that perhaps we're not going to be able to find all of the various ends of the branches on this big tree of life. So he went back to this idea of extinction. Said if you look at the fossil record, you're not going to find all of the species that are present in fossils present living on the earth today. So some species are going to get extinct. And if, for instance, we go back to this tree, maybe these were all extinct. So maybe what we're seeing are just going to be a few organisms that may not look a whole lot similar today, but if you trace them back, they did come from a common ancestor. So that common ancestor would be found at the most recent branching point. So if we look at this, Darwin's finches, he found finches that lived in trees. He also described some finches that lived on the ground. So they all diverged from a common ancestor. He said right here, that would in relationship to the tree that we're looking at here. And notice that the two sides of the tree are pretty different from each other. So all of them, though, did originally come from a common ancestor. Here's a look at elephants and the tree of life in regards to elephant species, or ones that are similar to elephant. So if we look at this, the most common ancestor on this tree would have been way back here at this first branch point. Now, if we look at the living organisms today, we have various elephants. So all of these, notice they look very similar to each other because they are very close on this tree. And then up here at the top, we've got manatees. Okay, manatees don't look a whole lot like elephants, but one of the reasons for that is because they did have a common ancestor that was very far in the past. So since that common ancestor, there have been a lot of changes that have taken place. And notice that in between the manatee and the elephant at the bottom, we do have other organisms there. But these are organisms that seem to be intermediates of the two, and they're organisms that are now extinct. So we have fossil records of these, but we don't have any living examples of them. So many of the kind of in-between species that would help us to connect pretty wide-ranging, widely different looking organisms with each other, they're going to be extinct at this point. And it's estimated that 99% of the species that we've ever had on this earth, they are extinct. Okay, so if 99% are extinct, the 1% that we're looking at, it's very likely that they're going to all look very different from each other.